Welcome back to the session, guys. Here we are going to learn the history of the embedded system. Before starting of the new lecture, let's recall the yesterday's topic. What we have learned yesterday is the definition of embedded system. It is the combination of hardware and the software, and it is designed for the specific purpose. Then we learned the classification between general purpose computer and the embedded system. So based on what will be the criteria, what will be the definition, that all we learned yesterday. So coming to this topic, today's topic is the history of the embedded system. Now according to the history of embedded system, the first recognized embedded system was designed by the Apollo guidance computer. It's called as AGC, and it is developed by the MIT lab. So what are the specifications? In the sense, specifications are 4K RAM was used. ROM is in the sense read-only memory, and 256 words of the RAM is used, and RAM is in the sense random access memory it is used. Now then clock frequency it's used. Clock frequency is for the 1 megahertz it's used. Then 16 word logic it was used, and this is the first EGC embedded system, first embedded system we can see like that. And as the number of years are increased, then microprocessor come into existence. Then to solve the overcomes of the microprocessor, microcontroller was designed again. And let's see that, in 1971 the Intel introduces the world's first microprocessor chip, and it is called as a 4001. Every microcontroller has its own features, and as the number of years increases, then as per the Moore's law, the number of ICs were implemented, that also increased, and the number of features that also has been increased. So let's see the video which shows that how the history of embedded system got changed drastically from the past years when it started, and now how commonly it is used everywhere, how embedded system are ruling the world. It's very nice video I'm going to show here. Let's start the video first.
History of embedded systems. At the end of this lesson, you will be able to explain the history of embedded systems, define the position of embedded systems in contemporary scenario. In the previous topic, you have learned how embedded systems differ from general computing systems. We know that embedded systems are designed using special purpose hardware and embedded OS to perform a specific set of tasks. It's very interesting to know about the specific tasks done through the embedded systems by exploring its historical events. Here we go. Have you ever wondered how the remarkable development of the embedded industry has made our life so simpler and easier? It is all due to the invention and development of semiconductor technology. Because without semiconductors, there is no microcontroller or microprocessor, and without them, there will be no embedded systems. Hence, it is important to know the efforts of various reputed industries which have made the embedded market more successful. So, let us take a look back at the major events that have marked the history of embedded systems. In 1944, the world's first programmable electronic digital computer was developed for the battle purpose. It was named as the Colossus Mark I and Mark II computers. The computer was specially designed and used by the British code breakers to read the encrypted German messages during the Second World War. In 1960s, a most crucial NASA's lunar mission program called Apollo Guidance Computer was started. The project was developed by Charles Stark Draper at the MIT Instrumentation Laboratory. This is the Apollo's guidance computer, and it was the first computer to use integrated circuits with 1 MHz clock, 4 kilobytes words of read-only memory, and 256 words of random access memory. This is the user interface, which has a 7-segment display unit with a keyboard. It acts as a communication bridge between the astronaut and the computer. It provided the astronauts to input their commands numerically. MIT professor David Mindel, who is the author of Digital Apollo, says the Apollo guidance computers were early examples of what we would today call embedded computers, which now appears in everything from iPhones to automobiles. Thus, Apollo guidance computer became the first recognized modern embedded system to this world. Later, in 1961, another one crucial military project was initiated. It was the Minuteman Missile 1. For this, the Autonetics D-17 guidance computer was developed. It was built from the discrete transistor logic and had a hard disk as its main memory. It was also the first embedded system to be produced in large quantities. In 1965, the first computer embedded in a commercial instrument was launched. It was a 12-bit PDP-8 mini computer. Consequently, in 1966, the Minuteman Missile 2 went on production. This came up with several major technical advancements in the Autonetics. It replaces the old Autonetics guidance computer with the new microelectronic guidance computer, which was lighter in weight compared to its older version. The second version was developed with a high volume of integrated circuits. This process reduced the cost of integrated circuits from $1,000 each to $3 each. Due to its affordability, integrated circuits came into use on various commercial products widely. In 1968, Intel was founded by Robert Noyce and Gordon Moore. The beginning of Intel led to the evolution of microcontrollers and microprocessors, which is the heart of many modern electronics. In 1969, microprocessor-based fuel injection system was introduced in the Volkswagen cars and was a breakthrough in the field of the embedded systems. In 1971, Intel 4004, the first 4-bit microprocessor, was developed by Intel scientists. In the same year, TMS 1000, one of the most successful 4-bit microcontroller, was developed by another semiconductor giant, the Texas Instruments. Further, in 1974, the Intel 8080 was developed and it was the first microprocessor to be used in a personal computer. And in 1980s, microcontroller became the demanded technology. The microprocessors are optimized for speed and memory size, whereas the microcontrollers are optimized for minimized power consumption and physical size. In 1983, HP 150 personal computer was introduced by Dave Packard and Bill Hewlett. It was claimed to be the first computer to be featured with touchscreen sensitivity. In 1987, VxWorks, a real-time embedded operating system, was introduced by Wind River Systems. And this real-time operating system was used for NASA's Mars Pathfinder mission in later year. In 1989, one of the embedded systems, dot matrix printer, was restricted to 8-bit due to power expenses and tight timing and electrical constraints. In 1992, the embedded systems went wireless and nearly 10 million mobile phones were manufactured using embedded systems for controlling their functioning. In 1996, the renowned software giant Microsoft entered into the embedded market and designed its handheld personal computer using Windows CE 1.0 operating system. Following with Windows OS in 1999, the Linux Foundation started to develop its roots in the embedded system. And at the beginning of the year 2000, a second parallel revolution occurred in the embedded systems. One of the highlights was the launch of the real-time version of Linux by TimeSys Corporation. In 2005, the multi-dollar companies Intel, IBM, and AMD released their first multi-core processors. And by the year 2007, the reputed American multinational technology company Apple released its first iPhone mobile. Following the Apple iPhone in 2008, the first Android phone was launched and the Android code became an open source OS. Finally, when it comes to our contemporary scenario, over 95% of electronic chips producing in a year are for embedded systems. These are hidden in familiar objects which you see around and use every day. Another one technological breakthrough in current embedded market is the Wi-Fi connected smart appliances. The range includes microwave oven, refrigerator, coffee brewer, washing machine, etc. And all these appliances can be monitored and controlled via your smartphone app. But what will be the picture of embedded systems in the future? Predictions say autonomous network will become the talk of the town in the future. One of the most awaited projects in this arena is the self-driving cars. It's a fully automated driverless car. Market players believing this technology is going to hit the streets soon by 2020 and it's going to change everything. Let's hope for the best. Summary. From this lesson, we have learned the history of embedded systems, the position of embedded systems in the contemporary scenario.
Let's come back. I hope this history is very much clear to you. We have seen very clearly, like according to year wise, what kind of evolutions has been taken place in embedded systems specifically, and what will be the future what will be the future of embedded system also. Now let's go for the next point. Now, for the next point, classification will cover after this point, after applications. So, come to the major applications of the embedded system. So, as we know that in every entire field, majorly embedded system applications has been used. There is no such a kind of field remain where embedded systems are not has been used. So, it's like you take any examples like automobile, telecommunications, smart mobile, missiles, satellites, computer network, everything. Now, let's take one by one. See, if we are talking about the consumer electronics, so cameras is one of the best example. Now talking about the household applications, washing machine, refrigerators, ACs, and all these things are come under the embedded system, is one of the embedded system application. Now automotive industry, where anti-locking braking system, engine control, this is one of the great best example. Then home automation, security system, ACs and the sprinklers, fire alarms are the examples. Now coming to the telecommunication, now cellular phones, telephone switches, networks, these are also the examples of the telecommunication. Now coming to the computer peripherals, the printers, scanners are also one of the examples of embedded system. Now coming to the network, computer network system, the network routers and the switches and the firewalls are also the examples of the embedded system. Coming to the healthcare, EEG, ECG scanners, all are the, which means it's called as a monitoring system. All monitoring systems are coming under the embedded system. Now banking and the retail, ATM, POs, say all are coming under the all are comes under the embedded system application. Now card reader, barcode reader, smart card readers, that all are come under the one of the embedded system applications only. Now measurement and instrument, in that digital multimeter, digital CRO, logic analyzers are the examples of it. Now coming to the wireless devices, then health and fitness trackers, smartphones, screen extensions for notification, these are all examples for the wearable devices. Now cloud computing and the IoT is also one of the extensions of the, I can say extensions or the futures, means one of the part of the embedded system, or we can say that the smart embedded system. So okay, so I hope this applications, and it's not compulsory like whatever we it is discussed here, that only the, that are only the applications of the embedded system and all. So it's not necessary like that. So based on your knowledge, you can categorize any category, and you can drop the examples also there. What we have learned in the today's topic is the history of the embedded system. We have seen that how the history of the embedded system is going to change from the first from the first embedded system computer to the till aid in the 2020 also, and what will be the future, that also we have seen. Now coming to the next is the application of the embedded system. That also we have learned application. We have seen actually the different areas of the application, where coming to the different sectors of the world, sectors, different sectors in the sense, in the home, in the industry, in the telecommunication, in the communication, whatever, in the operating system, in a computer, whatever, means everywhere, for the printer, scanner, different kinds of areas of applications we have seen according to the examples. I hope this video is clear to you. We'll meet soon, very soon, in the next video. Thank you so much.